Dear student friend, good evening. Welcome to ACE Online, digital platform of ACE Engineering Academy. In the present video session, we from Mechanical Engineering Department from ACE Engineering Academy would like to present the solutions for memory-based questions. So we are hoping you have performed very well in today's examination, and those who are opting for GATE, PI and XE papers, for them we wish you all the best. And from ACE Engineering Academy, so we are wishing you advanced congratulations. And we, from Mechanical Engineering Department, my faculty members are going to present the solutions for memory-based questions. And if you have any questions and if you have any queries, so please do share in today's a live session. So everyone, including us, so we are eagerly waiting for your responses, how you have performed the examination. Since you are our student, and definitely, so we have some kind of feeling how you have performed the examination and how you have done. And if you have any problem or if you have any queries and if you have anything you to share, please do share in this today's live session. And soon we are going to start the solutions for the memory-based questions. If you have any correct data, just try to upload so that we can present the correct solution for those questions. Yeah, welcome back to the live session. So right now we are going to see the weightage analysis. So based on your questions, so we have analyzed, and from where we had maximum number of questions and what kind of questions we had, just only we are presenting based upon your data. We are not sure about exact numbers and exact figures. So once you see the weightage, production technology, engineering materials, and IM and OR. If you see the production stream, from production technology 18 marks, from IM and OR 6 marks, from material science 1 mark. And come into thermal stream, as you know very well, thermodynamics, thermal engineering, just as usual same weightage. So 6 marks from 2 mark side and 3 marks from 1 mark questions. Heat transfer, this time less weightage, only 5 marks from heat transfer. And fluid mechanics, this time highest weightage, and the questions are really good enough and very, very easy. Those who have gone through our classroom practice book, even you can find a few questions directly from our book. I'm not exaggerating, just you can check it out. And very dead easy questions, and 4 questions from 2 marks, 8 marks, and 1 mark questions to 10 marks from fluid mechanics and turbo machinery. And coming to design stream, theory of machines, 2 marks questions are 3 and 1 mark questions 2. Strength of materials, usual weightage only, 7 marks. From machine design, 6 marks. Generally we expect same 6 marks from machine design, this time also same. Engineering mechanics, like a disappointed, only 1 question. And mathematics, 13 marks as usual. And if you see the paper, like most of your friends expressed that the paper is easy. Even I cannot say moderate, the paper is easy. So definitely you have to score more than 60 for getting IIT as well as IASC. Anyways, just once we get the total details, then only we can confirm the regarding your score and ranks. But if you have any difficulties or if you have anything, please do share in our live session. So this is regarding weightage analysis, and soon we are going to start the solutions for your questions. Like these questions, I told you already in the beginning itself, we were telling that we are receiving some numbers and some values, so which are not sure, and only for your satisfaction we are presenting the solutions, because everyone is curious about their paper and analysis. That only we are trying to help you, and just you can check it out. Like one of my colleagues, Malakonde sir, is going to start the session. He is going to present the solution for thermodynamics.
Hi students, welcome to the thermal part. This time total 6 questions asked from thermal. Out of 6 questions, 3 are 2 marks questions and remaining 3 are 2 marks questions. Now I am going to take the applied thermodynamics part. From the applied thermodynamics part, total 3 questions asked. Out of 3 questions, 2 are 2 marks questions, 1 is 1 mark question. The basic thermodynamics part will be handled by my colleague NP Raju sir. Now let us take the very first question, which is asked from the thermal power plant. It is asking like this: steam enters to a steam turbine of a steam power plant with no reheat and regeneration. The enthalpy of the steam at inlet is 3344 kilojoules per kg and entropy 6.5 kilojoules per kg Kelvin. That H1 enthalpy at the inlet of the turbine given 3344.33 kilojoules per kg, and entropy at the inlet of the turbine given 6.5 kilojoules per kilogram Kelvin. Okay, the steam expands with the turbine isentropically with an efficiency, isentropic efficiency. The steam expands in the turbine with isentropic efficiency 90%. Isentropic efficiency of the turbine 0.9, and exit condition of the steam having the following data. The data at the exit of the data for the steam at the exit of the turbine given Hg, Hf, Sg, Sf given. If the mass flow rate is 102 kg per second, then the power output of the turbine in megawatts up to 1 decimal place. What you do is, first you decide the dryness fraction of the steam at the exit of the turbine. That exit of the turbine, the dryness fraction can be decided by equating the entropies S1 equal to S2. S1 equal to definitely final quality is wet, S2 becomes S wet 2, S1 equal to S wet 2 equal to SF2 plus X2 into SFG2. As you know, SFG2 equal to SG2 minus SF2. From this you decide the SFG2, decide the X2 value. After deciding the X2 value, then H2, enthalpy of the steam at the exit of the turbine, equal to H wet 2. That H wet 2 equal to HF2 plus X2 into HFG2. After deciding the H2 value, the theoretical power of the turbine is mass flow rate of the steam into H1 minus H2. Then the actual power, since isentropic efficiency given, the actual power equal to the efficiency, isentropic efficiency multiplied by theoretical power. It gives the answer 100.1 megawatts. That is the answer. Okay, na? The another question from the Otto cycle. Look at the efficiency given for Otto cycle. Otto cycle efficiency given 0.5. If the ratio of specific heats, that is adiabatic index gamma given 1.4, the compression ratio is, you are asked to decide the compression ratio up to 1 decimal place. As you know, this is a very simple question. Otto cycle efficiency equal to 1 minus 1 by compression ratio power gamma minus 1. Right, you substitute all values for getting the compression ratio around 5.656. Since it is asked to correct up to 1 decimal, the answer is compression ratio equal to 5.6. That is the answer. Okay, similarly, look at the another simple question asked from the psychrometry. In a psychrometric chart, on one axis dry bulb temperature is represented, on the other axis which are the following. You know, the psychrometric chart is constructed at standard atmospheric pressure by taking the dry bulb temperature on the abscissa and specific humidity on the ordinate. Since it is asking the dry bulb temperature on the one axis, what is the value on the other axis? That is specific humidity. Option B is absolutely correct. So these are the 3 questions from the applied thermodynamics part. Now my colleague Madhusekar will handle material science part. Okay.
Right, welcome to ACE Online. I am here going to discuss memory based questions from material science and metal forming. Now material science, one question they asked. Now the question here it is, among the following surface hardening processes, steel is heated to the lowest temperature. See, in case of carbonitriding, okay na, in case of carbonitriding, the temperature is 700 degrees Celsius to 800 degrees Celsius. Okay, nitriding operation is the least temperature is required for this operation, only 500 to 600 degrees Celsius approximately. Okay na, cyaniding is also 750 to 850 degrees Celsius. Okay na, and carburizing highest actually 850 degrees Celsius to 950 degrees Celsius. So here lowest temperature surface hardening process is nitriding operation. Okay na, because in nitriding operation we are inserting, the nitrogen atoms are penetrating into the steel material, so we no need to heat the material up to austenite temperature. So B is the correct answer for this question. Now if we talk about the Y drawing, 2 questions they asked from the Y drawing, 1 question from rolling and 1 question from if you talk about the production, especially from metal forming, 2 questions they asked, 1 question from rolling, another question from Y drawing. Let us see the first question from the rolling. A plate of 30 mm thick Okay, this is the initial thickness. Let us consider H naught is fed through a rolling mill with 2 powered rolls, each of roll diameter. So diameter of the rollers given, diameter is 500 mm, and the plate thickness is to be reduced to 27 mm. Okay, now this is the final thickness H1. Okay, H naught is 30 mm. So plate thickness, initial thickness is 30 mm, final thickness is 27 mm, diameter is 500. Okay, now and friction is also given. So what they are asking, is this operation is feasible or not? Okay, if it is feasible, what is the maximum possible reduction in thickness, or we can say maximum possible draft? So what is the condition for successful rolling operation? What is the condition for successful rolling operation? Condition for successful rolling operation is friction angle must be greater than or equal to bite angle. Friction angle must be greater than or equal to bite angle. So tan beta greater than or equal to tan alpha. So friction angle tan beta, we can write it as a mu, must be greater than or equal to tan alpha. Tan alpha is nothing but under root delta H by R. So mu is given in the question 0.12, greater than or equal to under root delta H is 30 minus 27 by radius is 250. So this is satisfying. Okay, now this is satisfying, so that this operation is feasible. Okay, this operation is feasible, and maximum possible reduction they are asking. Okay, delta H max, maximum possible reduction is delta H max, that is mu square R. Delta H max is mu square R, that is 0.12 whole square into 250. By solving this, you will get approximately 3.6 you will get, so that the rolling operation is feasible and maximum possible draft is correct. So this is the correct answer for this question. Simple question. One more last question. Why drawing operation is performed on a perfectly plastic metal without any strain hardening, assuming no friction and no redundant work? The maximum possible percentage reduction in cross-sectional area. Okay, now see, what is the condition for maximum possible reduction in cross-sectional area? At the end of the deformation zone, the drawing stress must be equal to the yield strength of the material, because no strain hardening mechanism is applied here. So drawing stress is what, sigma D is equal to sigma Y ln A naught by A1, that is equal to sigma Y. So this one cancel out. So A naught by A1 is equal to e power 1. Now A1 by A naught is equal to e power minus 1. So percentage reduction in cross-sectional area. Okay, na? Percentage reduction in cross-sectional area they are asking. Maximum percentage reduction in cross-sectional area. So that is nothing but A naught minus A1 by A naught. Right? That is nothing but 1 minus A1 by A naught into 100. Okay, na? Now see here, 1 minus A1 by A naught is e power minus 1 into 100. So from this you will get 63.2%. So this is the answer for this question. So these are the questions related to material science and metal forming. Next, our colleague faculty Bari sir will continue fluid mechanics and fluid machinery.
Let us start questions in the subject of FM. 10 marks were asked in FM, that's quite a good weightage. We'll start with a 1 mark question, very simple question. The question is saying, consider a velocity field, velocity vector equal to 3z I cap plus 0j cap plus cx k cap, where c is a constant. For the flow to be irrotational, the value of c is equal to how much? Now you see, for irrotational flow, every rotation component must be equal to 0. If I wish to find out this component, then I'll go for rotation about y-axis is equal to 0. If you remember rotation about y-axis formula, it is going to be half of dou by dou minus dou by dou. Now since it is y, I'll write z over here, then x over here, x component of velocity over here, z component of velocity over here. This has to be equal to 0. What is dou u by dou z? U over here is equal to 3z. So dou u by dou z is equal to 3 minus dou w by dou x. Dou w by dou x will be equal to c. So 3 minus c is equal to 0. This implies the value of c is equal to 3. So the correct answer over here is 3. The acceptable range will be exactly 3. Nothing more or less than 3 will be accepted. There is no chance of any error. So therefore the answer will be only 3, nothing else. Moving further to the next question. Now this is a very, very regularly appearing question. If you remember, I have discussed this question in 2 places in your subject. Once in impact of jets and the other time in machinery. In the case of impact of jets, in the case of jet striking on a series of flat plates mounted on a rotating wheel, then also I told you for maximum efficiency the condition is the blade velocity is equal to half the jet velocity. Based on that only we are having a question. Let us read the question. The question is saying consider a Pelton turbine of 1 meter diameter, given to you 1 meter diameter. The magnitude of relative velocity of water at the bucket inlet is same as the magnitude of relative velocity of water at the bucket exit. Now what is the meaning of this particular statement from here to here? If the relative velocity while striking and exit are same, it means that we are neglecting the friction. In other words, the friction coefficient over here is equal to 1, k is equal to 1. The absolute speed of water, v is given to you as 125.66 meter per second. For maximum power output from the Pelton turbine, the RPM of Pelton wheel is equal to how much? Now maximum power output implies what? You are supposed to have maximum efficiency also. In such a case, you are going to use this particular relationship. So I can say now, u is the blade velocity, it is equal to pi d n by 60. It has to be equal to v by 2. From here you can get the value of n is equal to how much? It is equal to 60 v upon pi d into 2. So 2 pi d. 2 pi d. This is the value. If you put in the numbers, you will get the answer approximately as 1200 RPM. The answer will be 1200 RPM. So this is the value I am taking. Now of course there will be a small error coming over here, so they will be tolerating some kind of error over here, but the mean value will be 1200. Moving further to the next question. Now you see, this is the only question in the entire paper to have appeared from multiple thread questions. The question is saying for a fully developed pipe flow, did not mention what kind of pipe flow, just mentioned pipe flow, which of the following statements is or are correct? The first statement is, for same maximum velocity, the average velocity is higher in turbulent regime than in laminar regime. This is a correct statement. And how do I say so? Imagine that you are having a pipe flow. In this pipe flow, you are having turbulent velocity profile. Turbulent velocity profile would be almost rectangular velocity profile. And you are having laminar velocity profile. Laminar velocity profile is parabolic velocity profile. Both of them are having same centerline velocity. Both are having same centerline velocity. Now you see, this almost rectangular is for turbulent and parabolic is for laminar. You see, the discharge is going to be greater in the case of turbulent. If discharge is greater in the case of turbulent, therefore the average velocity will be greater in the case of turbulent. So from there, first statement is correct. Next statement, in laminar flow, the friction factor is independent of surface roughness. Perfectly correct. Friction factor in laminar flow through pipes is given by F is equal to 64 divided by Re. F is equal to 64 divided by Re. If you see the notes also in the characteristics of laminar flow, I have mentioned this statement. It is depending only on Reynolds number, has nothing to do with surface roughness. Moving further, compressibility effects are important if Mach number is less than 0.3. This is wrong. You see, the flow tends to be compressible if the Mach number goes beyond 0.3. If it is less than 0.3, compressibility effects are not going to be influencing our answers. So this is wrong actually. Next thing, for laminar flow, friction factor decreases with decrease in Reynolds number. अब देखिए, friction factor is inversely proportional to Reynolds number. So if Reynolds number is decreasing, that means the friction factor is supposed to be increasing. Therefore, this statement also is wrong. So correct answers over here are option A and option B. These two will be the correct statements. Again, let me tell you that whatever we are answering over here is based on the memory based data we have got. So if in case any data is different, the answers may be different. ठीक है ना? So let us move further. Next question. Now this question I would stay away from the slide so that you can see the entire question. As a matter of fact, this question is without any change in data present in CRPQ, classroom practice questions. Around page number 56, you will find question number 7 or 8, something like this, okay, with the same data. The question is saying over here, a pitot tube connected with a U-tube manometer, mercury manometer, measures the speed of air flowing in the wind tunnel as shown in the figure. The density of air is given to you as 1.23 kg per meter cube, while the density of water is 1000 kg per meter cube. For the manometer reading H equal to 30 mm of mercury, the speed of air in the wind tunnel is equal to how much? Given to you specific gravity of mercury as 13.6 and acceleration due to gravity is so and so. So you see over here, a diagram something similar to this is given. Now this is a direct question. The answer to this question is, velocity is supposed to be equal to root over of 2g into h dynamic. This is supposed to be the answer. अब देखिए, this is supposed to be the theoretical velocity. We'll go for actual velocity provided we are given the value of CV, coefficient of velocity. Since CV is not given to us, we'll not even bother about CV. Now the question is, what about this H dynamic? Since we are having over here a U-tube manometer connected, the value of H dynamic is supposed to be equal to how much? H dynamic is equal to H multiplied to SM by SW minus 1. This is the value we are having. So if I put in the numbers, V is equal to root over of 2G over here is given as 10. H dynamic is equal to, H is everything in SI units, so 0.03. SM by SW can be equal to density of manometric to density of working. Density of manometric is 13,600. Density of working fluid is 1.23 minus 1. Because the working fluid is air over there. If you simplify this, you will get the answer of around 81.446 meter per second. Okay, 81.446 meter per second. I'm assuming the correct answer range acceptable will be around 80 to 83. Okay, this is the answer to the question. Moving further to the next question, a very simple question from similarity analysis is given. The question is saying, in a laboratory experiments using a scaled down model to measure score at a bridge pier, the Froude number is important. Okay. So it is given to you that Froude number analysis is done. The ratio of prototype length to the model length is equal to 100. That means LR, length ratio, which is length of model to length of prototype, is given to us as 1 by 100. If the velocity of the model is equal to 1 meter per second, velocity of the model is equal to 1 meter per second, the velocity of the prototype is equal to how much? How do we answer this? I told you that whatever type of model we are doing or we are using, all we are going to do is, we are going to say that number ratio has to be equal to 1. So in this case, since the question has already mentioned Froude number, we'll say Froude number ratio is equal to how much? 1. The formula for Froude number ratio is what? Velocity ratio upon root over of LR times GR is equal to how much? 1. Now GR is gravitational acceleration ratio. It is always 1 as long as model and prototype, both of them are on Earth. So GR is 1. From here we get that the value, I'm continuing over here. From here we get the value of VR is equal to root over of LR. VR is equal to root over of LR. So what do I have over here? Velocity of model by velocity of prototype is equal to root over of LR. It is equal to 1 by 10. So velocity of prototype is equal to how much? 10 times velocity of model. Velocity of model is already given to you as 1. So it has to be equal to how much? 10 meter per second. So velocity of prototype is 10 meter per second. option C will be the correct answer over here. So answer is 10 meter per second. Moving further to the next question, very easy question. Okay, the question is saying consider two identical tanks with a bottom hole of diameter d. One tank is filled with water, other is filled with engine oil. The height of fluid column H is same in both the cases. The fluid exit velocity in two tanks are V1 and V2. Neglecting all losses, which one of the following options is correct? अब देखिए, this is such a simple question. To answer this question, all you are going to do is apply Bernoulli equation between this point and the exit point over here, and from there you get a Torricelli equation which is saying that velocity is equal to root over of 2gh. अब देखिए, this 2gh is independent of what fluid you are taking. Whether it is water or engine oil, the value of root over of 2gh is going to be same in both the cases, and so I can say the value of V1 has to be equal to how much? V2. Very simple question, basic Bernoulli equation question. ठीक है? अच्छा, those were the questions from the subject of fluid mechanics. I am assuming they were quite simple to you. Let me look at two questions from mechanics as well. The first question over here is saying a rigid circular disc of radius r in meter is rolling without slipping on a flat surface as shown in the figure below. Now this question has appeared so many times. We have discussed this question in the class as well, if you remember. The angular velocity of the disc is omega. The velocities at point O and A respectively are equal to how much? Achha, let me also add one more thing over here. The question, I believe, was giving the direction sense x and y like this. Whenever these kind of questions come, they are supposed to be giving this. So if they have not given, I'm adding these things over here. ठीक है ना? Now, in the case of rolling without slip, one thing we know, if the surface is stationary, the point of contact is supposed to be having zero velocity. So if it is having zero velocity, either option A is correct or option C is correct. Now the question is, point O will be having how much velocity? Point O, the velocity of the center I told you is equal to r times omega in case of rolling without slip on a stationary surface. So r times omega is correct. Now the question is it in positive x-axis or negative x-axis? Very simple. This is your eye center, make it rotate in the clockwise direction sense. If you make it rotate in the clockwise direction sense, it is point O is going in the positive x-axis. So therefore this is going to be r omega I cap. So from here we get the answer as option A. Option A is correct over here. Moving further. Very simple question again. We have had a good discussion on the concept of zero force members in trusses and frames. This question is saying a truss structure is loaded as shown in the figure below. Among the options given, which member in the truss is a zero force member? Okay, I told you two concepts in zero force member. One concept is if a joint is having three members such that two are aligned in the same line, collinear, and one is non-collinear, that member has to be a zero force member. So according to that logic, you see BD over here happens to be a zero force member. Apart from BD, any other member if you check is loaded actually. Because of this particular loading, this will be loaded, this will be loaded. These two will be having same loading, again this will be loaded. So all the other members are having loadings, only member which is having zero loading is BD member over here. So these are the questions on the subject of fluid mechanics and engine mechanics. All the best to all of you. I hope the solutions were understandable.
Good evening everyone. I am Dr. N.P. Raju, Thermodynamics faculty, going to discuss thermodynamic questions. This is the first question. A heat pump is given operating in reversed Carnot cycle. Reversed Carnot cycle, it is a theoretical cycle or hypothetical cycle for heat pump, maintains a steady air temperature of 300 Kelvin. Inside an auditorium, there is some auditorium in which the temperature is 300 Kelvin. The heat pump receives heat from the ambient air. The ambient air is at 280 Kelvin, ambient air, which is atmospheric air temperature 280 Kelvin. Heat loss from auditorium is 15 kilowatt. Heat loss is given from auditorium 15 kilowatts. This is what data given. The power consumption for the heat pump in kilowatts. We need to find power consumption. This is the given question. Let's take rough diagram. Taking this diagram, it's a rough diagram of heat pump where this is high temperature cabin. Actually in this question auditorium is given. So here auditorium or cabin which maintains at high temperature, that is 300 Kelvin. Temperature is given 300 Kelvin. And the heat pump receives heat from ambient air, and ambient air is at 280 Kelvin. Ambient air, which is nothing but atmosphere, and compared to this temperature, cabin temperature outside, ambient temperature will be low, which is given 280 Kelvin. Ambient temperature is given 280 Kelvin. So this is high temperature 300 Kelvin, this is low temperature or ambient temperature, that is 280 Kelvin. So this is what given, and there is heat loss from the auditorium, which is extremely important point. He said heat loss from auditorium 15 kilowatts. So this is auditorium or this is the cabin where high temperature is required, and there is heat loss. There is heat loss. And please try to understand the point which I am going to explain. As there is heat loss from the auditorium, it may be auditorium, it may be a room, or it may be any other place where high temperature is required. Heat pump is used to supply heat where high temperature is required. So there is a heat loss from the auditorium or there is a heat loss from the room. Please try to understand, whatever the heat loss is there, same amount of heat has to be supplied to the cabin or room or auditorium. So he said heat loss from the auditorium is 15 kilowatts. Heat loss is 15 kilowatts. This is the heat which is being lost from the auditorium. Whatever the heat loss is there, same amount of heat has to be supplied to the auditorium, where Q1 is nothing but heat supplied to the auditorium. Therefore, Q1 has to be equal to 15 kilowatt. I repeat, Q1 is heat supplied to the auditorium, which has to be 15 kilowatt, because the reason being is that heat loss from the auditorium is 15 kilowatt. Whatever the heat loss is there, which has to be supplied to the auditorium. Therefore, Q1 has to be 15 kilowatt. And it is a straight question. So he is asking power consumption, and reversed Carnot cycle is given. COP reversed Carnot heat pump, or simply COP Carnot heat pump, reversed Carnot heat pump, no problem. COP reversed Carnot heat pump, which equals to T1 upon T1 minus T2, which is also equal to Q1 by W. Since reversed Carnot cycle is given, temperatures will come into picture, T1 by T1 minus T2, which is also equal to Q1 upon W. Already temperatures are given, T1 is 300 and T2 is nothing but 280. Let us substitute the values. T1 300 and T2 280, which is equal to Q1. Q1, I just know, as I explained, Q1 has to be 15 kilowatt, 15 upon W, which is to be calculated. If you calculate W, it comes out to be 1 kilowatt. So actually 15 kilowatt, this is rate of heat transfer, this is the Q dot, and W dot has to be calculated, that is power required or power consumption. Therefore, W comes out to be 1 kilowatt. So this is the answer for this problem. Power consumption required is 1 kilowatt. Going to the next question. A thermodynamically closed system contains 1 kg, mass is given, mass is 1 kg of hydrogen, H2 gas is given. The system undergoes a reversible polytropic process. Polytropic process is given. The polytropic index is 1.3, which is N. N equals to 1.3. Polytropic index. The work output during the process, work output of the system, work output is 400 kilojoules. W 400 kilojoules. Right. The hydrogen behaves as an ideal gas with constant specific heats. The absolute value of heat transfer during the process. Heat transfer has to be calculated in kilojoules. Cp is given 14.56 kilojoules per kg Kelvin. Cv is given 10.4 kilojoules per kg Kelvin, and round off to 1 decimal places. Right. This is the data given. Right. Cp, Cv is given. Right. So taking rough diagram, he said it's a rough diagram. Actually, hydrogen gas is given, H2 gas is given, H2. Actually, it is H2 gas, and he said there is work output from the engine. Work output. He said work output of the process is 400 kilojoule. Work output means it is expansion process. During expansion, there is work output which is 400 kilojoules. So heat transfer to be calculated, and it is a straight question, straight and easy question. During polytropic process, in polytropic process, the heat transfer formula is Q is equal to polytropic heat transfer. Heat transfer polytropic process is equal to work transfer polytropic process into gamma minus N by gamma minus 1. Work transfer polytropic into gamma minus N by gamma minus 1. This is the formula. It is a straight formula. Already work output is given, which is 400, and polytropic index is given 1.3. Only unknown is gamma. If you find gamma, problem is over. But please note that since hydrogen gas is given, H2 gas, hydrogen which is H2, directly we cannot take gamma value. Why? The reason is Cp, Cv values are given. If Cp, Cv values are supposed not given directly for hydrogen, because monoatomic gas gamma is 1.67, diatomic gas H2, N2O2 1.4 directly can be taken, and polyatomic gases like CO2 and CH4 1.33. Since Cp, Cv values are given, we have to calculate gamma value. There is no other go, we have to calculate gamma. Gamma is Cp by Cv. Cp 14.56 and Cv 10.4. So it comes out to be 1.4. Gamma is 1.4. So directly we can substitute W 400, gamma 1.4, N is 1.3. If you calculate, it is going to be Q polytropic. It is 100 kilowatts, 100 kilojoules. So this is the answer for this problem. It is a straight and easy question. Going to the next question. Air is given inside a rigid thermally insulated tank undergoes stirring process. Stirring means which is stirring process. There is a stirrer which in this problem diagram is also given. So there is a rigid and insulated tank. Insulated, there is no heat transfer. Insulated, no heat transfer. Heat transfer will be 0. And it is a rigid, thermally insulated tank, and there is a stirrer. And stirrer is rotated, thereby some work is going to be done on the system, right? Shown in the figure, which one of the following options is correct? Correct, we are asked to find correct statement. First option, option A, both enthalpy and entropy are constant. By the way, air is given, air behaves as ideal gas. And for an ideal gas, enthalpy and also internal energy function of temperature. For an ideal gas, enthalpy function of temperature, and also internal energy also function of temperature. Since options are given with respect to enthalpy, I have taken enthalpy. So as the temperature increases, enthalpy also increases, direct function of temperature, enthalpy direct function of temperature. And by the way, here as the stirrer is rotated, when stirrer is rotated, these are air molecules. So these air molecules also getting rotated and they collide. Molecules, they get collided. Therefore, due to collision, temperature increases. Due to collisions of molecules, temperature increases. If temperature increases, enthalpy also increases because direct function of temperature. Enthalpy is function of direct function of temperature. As temperature increases, enthalpy must increase. So both enthalpy and entropy constant, he said. Straight away, this is wrong because enthalpy, he said, constant, wrong. B, enthalpy decreases, straight away, wrong. Enthalpy increases, partially correct. Then entropy. What about entropy? Entropy is nothing but disorderness of molecules, randomness of molecules. As the stirrer is rotated, molecules getting collided, thereby entropy increases. Because of the molecules collision, it is a stirring process. Because of molecule collision, entropy increases. So enthalpy increases, entropy constant, wrong. And option D, enthalpy increases, correct. Entropy also increases, correct. Therefore, for this problem, answer is option D. So that's all for thermodynamics, and next our co-faculty will continue. Thank you.
Yes, now we have to see the questions of production subject. Already Madhushekar sir completed metal forming sheet metal. There was no question on sheet metal, but he completed that metal forming question. Now you have to see some casting and welding questions. Now see, this is the first question here on the casting 2-mark theory question. You can see the scheme bob here, match the pair. You have to see scheme bob. What is the work of scheme bob? It can remove the impurities. It can remove, or removal of impurities. We can write the removal of impurities is the correct answer. Next, core. Core is used for producing the hollow casting. Then you can see what will be the answer. Casting with internal cavities means hollow casting we are going to produce. Then the answer of core is this, casting with internal cavities. Insulating sleeve means some insulations we are giving, and because of insulation the heat transfer will be less, and therefore the solidification time will increase. And this is the correct answer here. In inoculant. Inoculant means what? There is some alloys. In that alloys, if we are doing the casting of alloys, then mechanical properties will be not good. Therefore, to improve the mechanical properties, we have to add some metal in the molten metal, and that is called as inoculant, and it is known as nucleating agent. Next, steel assist in faster heat removal from the melt. Okay, chill is it is going to chill the casting, it is going to cool the casting. Next is a blind riser, that is molten metal reservoir. That is, the riser is what? Molten metal reservoir. These all are the correct pairs. Next, two metal parts, a cylinder and cube. Means two casting we have to do, one is cylindrical casting and one is cubical casting of same volume are cast under identical condition. That is what is important here, the volume is same. Therefore, here I am going to write the volume of cylinder, it is very important data, is equal to volume of cube, very important data. What is the volume of cylinder? That is pi by 4 d square h. But read the total data here, the diameter of the cylinder is equal to height. Very good data here, the diameter of cylinder, that is the diameter of cylinder is equal to height of cylinder. Okay, then we can write the volume of cylinder pi by 4 d square h. Height is equal to what? Diameter. Then I am writing the diameter, the volume of cube. The side of cube we can consider a or x. I am considering a, then it is what? A cube. Okay, right. Then here we can get the relation, guys. The a is equal to cube root of pi by 4 into of d cube. Then cube root of pi by 4, I think 0.92 d. A is equal to 0.92 into d we can get. Okay. The ratio of solidification time of cube, the ratio of solidification time of cube to the cylinder we have to calculate, that ratio we have to calculate. Okay, and which rule? The Shorino's rule we have to follow here, very easy. Okay, then here I am writing the solidification time of cube to the solidification time of cylinder is equal to modulus of cube divided by modulus of cylinder whole square. Guys, here the modulus is d by 6, but modulus of cube is a by 6 and modulus of cylinder is d by 6 whole square. You can see the 6's get cancelled, then it is a by d. But what is a here? A is 0.92 d. A is 0.92 into d divided by d whole square. You can see dd get cancelled, and here solidification time of cube to the solidification time of cylinder, that correct answer we can get, that is the 1.18. Yes, this is the correct answer, 1.18 is the correct answer. Okay. Then you have to do the square of 0.92, right. Now, next question here. Yeah, this question, guys, it is not on casting. This question you can see on additive manufacturing. Okay, we don't have the correct question, guys, therefore you try to understand this question here. But what is going to happen in the stereolithography? Stereolithography, you can see in stereolithography we are using the liquid. It is a liquid based rapid prototyping system, and which liquid we are using? We are using the epoxy resin as a liquid. Epoxy resin liquid we are using here. Then this is the correct pair here. FDM, fused deposition modeling, it is like the extrusion process. Then extrusion of melted polymer means some plastic material we are going to extrude here, and then ABS material also we can use in the FDM. The laminated object manufacturing, laminations are there, the sheets are there. Then you can see the sheet metal deposition, and which sheets we can use, the paper sheets we can use it here. The next is laser engineered net shaping, means laser we are going to use. Then here injection of powder stream, means we have to put the powder, then by using the laser the powder will convert into the heat. Then which powder we can use here? The titanium powder we can use it here. Now see next question. Yeah, this is the question, guys. Very rarely they are going to ask the question on CAD, because we are in the syllabus, the CAM is there, computer aided manufacturing, but sometime by mistake they are going to ask the question on CAD. And this is the CAD question, somewhat difficult question, not easy. In a CAD computer aided design, the solid model can be constructed using, we have to make one solid component, solid model, and for that we have to go with the boundary representation, that is B-REP we are going to say. Non-uniform rotational B-splines, Bezier curves B-spline, that all are the curves, but this option A first is giving the solid model. Yeah, next is a very easy question, casting the liquid metal. Casting question again, a liquid metal is poured in a mold cavity. Here the volume is given, guys, 200 by 200 by 200. Volume of casting is given 200 by 200 by 200. Then I am writing here the 200 cube millimeter cube. The cooling is in all direction, heat transfer is from all direction with no additional compensation for shrinkage. This is very important, no additional compensation for shrinkage, means riser is not there. We are not going to provide any riser here, no compensation. considering the volumetric shrinkage during solidification and solid contraction. Solidification means stage 2 of cooling, solid contraction is the stage 3 of cooling, and it is given the 7%, 8%. Then how we can get the length of the cube edge after cooling down to the room temperature. Okay, then I can write the volume after shrinkage. Volume after shrinkage. Firstly, I am calculating volume after shrinkage, that is the 200 cube. Then here the first you can see the 7% is there, that is the solidification shrinkage. 7% means here I am writing the remaining is 0.93. Repeated question. In the previous year GATE exam also they asked the same question. Then 8% means here I am writing the 0.92. Okay, then here we will get some volume. Okay, then what is the volume here? The LBH3 lengths are there, then it is L cube. L cube is equal to, we will get some answer here. Then length we can get, that is 189.86 millimeter is the final answer. Number of questions around 5 mark weightage only from small chapter, that is the casting is there. Yeah, now see the next some different question of welding. During welding operation, thermal power of 2500 watt, the power is given 2500 watt, is incident normally on a metallic surface as shown in figure. When on the surface, the power we are going to give on this surface here, you can see the radius of 5 millimeter means you can see the power we are going to apply here. You know, this radius is 5 millimeter. Then in that area we are going to apply the power, that is the 2500 watt. You can see the power is equal to 2500 watt. The power we are giving. Okay, the heated area is circular. The circular heated area is there. Out of the incident power, 85% of power is observed, 15% is going to lose. Within the circle of radius 5, while 65% absorbed within the inner concentric circle of radius 3 millimeter, the power density in shaded area, guys, this is the shaded area. This is the shaded area, guys. Then we have to calculate the power density in this shaded area. We have to calculate. This is the shaded area, and we have to calculate the power density in shaded area. Power density. Okay, power density is watt per millimeter square, that is power divided by area. Power divided by area. In which year we have to calculate the power density, the shaded area. What is the shaded area? Here the radius is given, that is I am writing the pi into r square, that is 5 square minus pi r square, that is pi into 3 square. Okay, we got here the shaded area. What about the power? Power is 2500 watt, but guys, in the shaded area what power we can give here? You can see the 0.85 minus 0.65 into this power is 2500 watt. Only this power is going to supply to that shaded area. Okay, this power. Therefore, the answer of here power density is 9.94 watt per millimeter square. Okay. Now see next question here. The welding process commonly used for fabricating the tailor welded blanks of dissimilar thickness for automobile application. Guys, where we can use the gas welding, at the same place we can use the arc welding also. But here this is not a multiple select question, but a dissimilar thickness is there, guys. Dissimilar thickness, you can see the welding process commonly used for fabricating tailor welded blanks of dissimilar thickness for automobile application. Definitely the friction welding we are not going to use, because if some bars are there, means circular cross section is there, 2 rods we have to join, 2 bars we have to join, then the friction welding is better, we can go with that. But here not like that, dissimilar thickness, then correct answer is only option, that is laser welding. Yeah, very easy question. The ceramics and glasses are machined by ultrasonic machining method, mechanical energy method is there, USM there is again option, abrasive water jet machining is there, then but that abrasive water jet or abrasive jet machining is not available in option. Otherwise the multiple select question can make. In EDM the ceramics glass are not conducting, EDM ECM is not answer, and plasma are machined is also not answered. The correct answer is USM. Correct answer is USM. Okay. These are all the questions of which topic? The casting, welding, advanced machining method, non-traditional machining method. But now the two questions are remaining from the part metal cutting. There is no question on machining, but there is one question on metrology. Now see the first question of metrology here. When assembled the whole of 30, these limits are given, the lower and upper limits are given here, lower limit 0 and upper limit is plus 0.030, and a shaft of here the 30 plus 0.020 and here minus 0.020 will be result in, I am not going to explain in detail, very simple part here. The correct answer is what? Clearance fit. It is not interference, it is not a transition, it is not a loose, simple. It is transition fit, not guys, clearance fit is not answer. The correct answer is what? The transition fit is correct answer. Okay, it is a case of transition. Okay, now see the one question here, very interesting question here of metal cutting chapter. One important topic is there, somewhat difficult. Now see, I am writing given data, cylindrical workpiece. Guys, we have one cylindrical workpiece, we have to do the machining of that workpiece and its diameter is given 60 millimeter. Very big solution is there here, 60 millimeter. The length of that cylindrical workpiece is 400 millimeter. Are machined on a lathe at a cutting speed, great cutting speed is also given, that is velocity is given, that is 25 meter per minute. Okay, and a feed of F is 0.2 millimeter per revolution. The Taylor's two-life parameter, the C and N is also given, the almost all the data is given. C is 75, N is 0.25 respectively. The tool changing time is 3 minutes. The tool changing time, I am writing the TC is 3 minutes. With the labor and overhead cost, I am writing the labor and overhead cost is 5 rupees per minute. I am writing directly the cost here, 5 rupees per minute. That is labor and overhead cost for 1 minute is 5 rupees. The tool changing cost per piece is the tool changing cost. Tool changing cost per piece. Per pieces. Means guys, here the number, we have to work with the number of work pieces, and in that number of work pieces, what is the tool changing cost for one work piece we have to calculate. What is the tool change? Means we have to change the tool. Then what is that tool changing cost for one work piece is there. Okay, then guys, here the firstly we are going to calculate here the tool life. We have the great equation V2 raised to N is equal to C. Here the V, you can see the 25 into that is T, N is 0.25 is equal to the value of C is also given the 75. Then here we got the tool life, that is the 81 minute. Okay, this is what we got here, the tool life. This is the life of tool. But what the machining time is required, then I am writing here the machining time. Here the machining time I have to write, that is the TM is the machining time, the famous formula L divided by Fn is there. What is the length of workpiece here? The 4. What is the feed is given here? F is, you can see the 0.2. What about the N? We don't know what is N, but we know that the velocity is equal to pi dN by 1000. I am writing the pi dN by 1000. Therefore the N is equal to, I am writing the 1000 into that velocity is 25 divided by pi into what is the diameter here, the 60 I am writing. Then guys, here we are going to obtain the answer of N, that is 132.63 RPM, and that same I am putting here 132.63. Okay, then here we can get the machining time here. Then I am writing here the value of answer, that is the machining time is 15.08 minute. 15.08 minute. Okay, then this 15.08 minute for one work piece is there. What is the total tool life for one? What is the life of one tool? 81 minute. And here the machining time for one work piece is 15.08. Okay, the next you can see here the number of work pieces. Machined. number of workpieces are machined here, means you can see the tool life 81 minute, and in that 81 minute how many workpieces can machine, that is the machining time for one workpiece is 15.08 minute. Then number of workpieces can be produced with one tool, can be machined with one tool. One tool is equal to here the T by Tm, then total T is 81 and Tm is 15.08. Then here the number of workpiece machined with one tool, how many? Just you can see the 5.37. 5.37 is the answer. Okay, now here you can see that what we have to calculate tool changing cost per piece. For one piece, what is the tool changing cost? Then I am writing here the total tool changing cost. Total tool changing cost. Yes, now here you can see the total tool changing cost. Here you can see the tool changing time 3 minutes into this 5, 3 into 5 is equal to 3 into 5 here, then is equal to, here the answer is 3 into 5, that is the 15 rupees. Okay, this answer is 15 rupees per tool. That is tool changing cost for one tool is 15 rupees. What final we want the tool changing cost per piece. Tool changing cost per piece. Tool changing cost per piece is equal to this 15 divided by 5.37. Then here the correct answer is 2.97. Here the 15 rupees per tool, and here how many work pieces are here, the 5.37 work pieces. Then here the final, the tool changing cost per piece in rupees is, this is the final answer. With this, this question, metal cutting question is also completed. There was no question on machining. Now here the total production questions are completed. Now the next subject will be machine design. The answer will come.
Let's see the solutions of machine design. So here there was a question on welding. So this was the question. This was the fillet weld. So there were two plates which were placed one above the other, and there was a weld here at this location. Now here in this case it was told that the load which is acting over this plate was having some magnitude P, and he's asking us to find what is the length for this length required for bearing this particular load. Now here in this case we know that the load has to be kept below its capacity. What is the capacity? So here he gave the material strength. So S into the throat area of throat. Okay. Now here what is the material strength that is given? P has to be lesser than or equal to material strength is given as 200 megapascal into, we know that throat area is throat thickness into length. What is throat thickness? 0.707 times H. So here the size of weld is nothing but equal to the thickness of plate, which is given as 10 into L. So here what is the length that is required? Length has to be greater than or equal to P divided by, so 200 into 0.707 times 10. This was the answer. Now here, as the data was missing, so if you substitute the value of load in this equation, you'll get the value of required length for this case. Now moving to the next equation. So in this case, he has mentioned that this is the fluctuating loading concept. Here he says that the endurance limit, which is SE, is equal to SYT. So that's nice. So here he also says that the ultimate strength is twice its. So SUT is given as twice its yield strength. So nice. So for a factor of safety of 2 using Soderberg criterion, the maximum allowed tensile principal stress is. So here he is asking us to identify the maximum possible stress here in the fluctuating loading condition. What is Soderberg case? So we know that it is mean divided by SYT plus amplitude divided by SE is equal to 1 by factor of safety. Now here we know that SE is also equal to SYT, or SYT is also equal to SE. Here all these options are given in SE. I'll replace SYT as SE here. Now here if you send SE to this side, so we'll get mean plus amplitude as SE by factor of safety. Factor of safety is 2. We know that the mean plus amplitude value is nothing but maximum. The maximum possible value here, the maximum possible stress is nothing but equal to 0.5 times SE. See, as we do not know what is the exact question, see on the base of, as this is memory based question, yes, based on that particular data, the answer for this question is coming out to be C. Now there was one more question, very easy one. Here he was asking us to identify the material yield strength in shear. So we know that according to von Mises, SYS according to von Mises is nothing but equal to SYT divided by root 3. So here what is SYT? SYT is given as 200 divided by root 3 megapascal. This is our answer. And there was also one more question from machine design, that is from bearings. So here in that particular question he has asked regarding the classification of bearing. So that was also, so I was told that that was an easy one. So here there were 4 questions from machine design, so a total of 6 marks, as you can easily get from this particular subject. Moving to strength of materials, let's see, there was a question here which was asked, the state of stress at a point. Here this is the plane stress condition. For this case he is asking us to identify what is the strain in Z direction. Now here we know what is the strain equation in Z direction, as this is plane stress. This is sigma x value, sigma x is 350, and here you can notice that sigma y is compressive, sigma y is equal to minus 150. Okay, he is asking us to find epsilon Z, which is nothing but equal to minus mu by E into sigma x plus sigma y. Okay, now what is mu value which is given? Minus 0.27 divided by E value here is given as 200 gigapascal into 10 power 3 megapascal into sigma x is how much? 350 minus 150. So here 200 and 200 cancels out, we'll get this as minus 0.27 into 10 power minus 3 mm per mm. So this is what is the strain that we get in Z direction for the given loading condition. I hope so you have got this answer. This is an easy one, by the way. And here he has asked, what is the Mohr circle for hydrostatic case? Yes, we know that the Mohr circle for hydrostatic loading is a point. That is a point. Okay. So here, so if that is pressure, if pressure is considered to be negative, obviously if that is under compression, so the graph will come out to be on the negative side. Why? Because so it is in compression, right? If that is, as again the concrete information is not given, if that is tensile or if either that is pressure or not. So here if that is pressure, D will be the answer. If at all if that is tensile, so answer B will be, so B will be your answer. So moving to the next equation. An isotropic brittle material is tested. So here in this question he is asking us to identify what is the strain energy density. So as we know that the total area below this graph is going to give us the total strain energy density. Now here what is the area? Here we have 2 blocks. So here this is a triangular block, and this is a trapezoidal block. If you add the area of these two blocks, you will get what is the total strain energy density. So what is the area of this triangle? So area of this triangle here is nothing but equal to half base is what? Base is 0.01 into height is how much here? 100 plus. Now here, what is the base of this trapezium? So the base is nothing but 0.005. So here it is nothing but 0.015 minus 0.01, which is nothing but this distance is nothing but 0.005 into the average height. What is the average height of this? 100 plus 120 divided by 2. So here the answer for this case comes out to be, by the way, the answer is coming out to be 1.05 Newton per mm square. As we know that here the unit here which is asked is megajoules per meter cube. So here you can add mm. So obviously, so the unit for strain is mm per mm. Now here Newton mm. So I can write this as, so here this can be converted to, so 1.05 megajoule per meter cube. So here again, so this is nothing but equal to megajoule per meter cube. Okay, so the answer here is 1.05. Now moving to the next question. Wow, an extraordinary question he has asked. He has asked what is the bending moment at the midpoint. Now exactly at half a distance, what is the bending moment is what is the question here. Now here as you can notice that the bending moment here is clockwise. So here, so this is distributed. This bending moment was distributed in such a way that it is acting as, so this is uniformly distributed in the fashion that it is 1 Newton meter per meter. The distribution is per meter, how much is distributed? 1 Newton meter. This is what is the distribution which is given. Now here, we need to identify what is the bending moment at the center point. So an extraordinary question. Now here as it is clockwise, we can notice that here as it is trying to move down, the reaction will be acting in upward direction. Okay. Now I need to identify either of the reactions, either the reaction at B or the reaction at A to find the bending moment at the center. So what do? I'll take moment at A now. So the summation of moments at A is equal to 0. RB into 1 is nothing but equal to, what is the total moment that is acting here? So it is 1 Newton meter per meter into what is the length here? 1. Now here the reaction at B comes out to be how much? 1. So this is 1 Newton. 1 Newton is the reaction that we have at B. Now here what is the moment that we have at the midpoint? Moment at midpoint is nothing but equal to, so here the counterclockwise moment plus clockwise moment. So you need to add both the moments so that you'll get what is the value of magnitude of moment at the center. What is the counterclockwise moment here? So 1 into the counterclockwise moment. So here RB is at a distance of 0.5. So here minus clockwise moment as this is distributed here. So it is nothing but equal to 1. So 1 Newton meter per meter is distributed. So here how much is the length over which this is distributed? It is 0.5. So if you see here 1 into 0.5 minus 1 into 0.5, so both cancels out, the answer is coming out to be 0. So here it is a simple question, very easy one. Okay, so we can easily say that for this case the bending moment at the center position is nothing but equal to 0. These are few questions which we have got from strength of materials. Now we'll try to solve some questions from heat transfer. Okay, let's proceed to the next one. Now here this was a question on heat flux. So here there was heat addition to this member continuously, similar to the previous question. Here this heat addition is uniformly, so it is uniform here. I can notice that the heat flux here is nothing but equal to, here the value of Q is given as 2000 watt per meter square. And here the water is flowing within this pipeline. And here he says that as it is entering and exiting, so at the inlet the temperature is 293 and at the exit the temperature is 353. For this case, so what is the total length that is required is what is asked. Okay. Now here we can easily understand that whatever is the heat addition is nothing but, so by considering energy conservation, energy in is equal to energy out. Okay. So what is the energy in? En is equal to, or heat in is equal to heat out. Okay. Now please say me, okay, let's observe carefully. Whatever is the energy absorbed, I can say that this is what is the energy absorbed. Okay. Now here, what is the Q in here? Q into the surface area that we have is pi d into what is the total length L is equal to what is the how much is the heat that is absorbed, the rate at which the energy is absorbed is, so here the mass, the rate of mass is given, okay. So m dot into Cp into delta T. Okay, so there is rise in enthalpy here, so we can easily understand that yes, the addition here, the amount of heat added to the water is nothing but equal to mCp into delta T. All these values of the Cp value for water is given, you need to substitute the values to get your answer. So this is 2000 into pi into diameter for this case is given as, what is the diameter for this? So diameter here is given as 60 mm. So we need to substitute that in meters into length. The rate of mass here is nothing but equal to 0.01 kg per second into Cp value is given as 4181 joule per kg Kelvin into the difference in temperature here is 353 minus 293. With simple calculation, we'll get the value of L. The required length here is 6.66 meter. Okay. So with simple calculation, yes, we are getting the answer as 6.66 meters for this case. Okay. Now moving to the next question. So this was the question which was asked on radiation. Now here you can notice that there are three different surfaces. Here he is asking us to identify. So the amount of heat transfer between 1 and 3. Q13 is asked here. Now we can write the equation for Q13 as, okay, A1 F13 into sigma into, so T1 power 4 minus T2, that is T3 power 4. Now here this is what is the amount of heat transfer that we have between 1 and 3. Now here as F13 is required, here F12 is given. We know that F11 plus F12 plus F13 is nothing but equal to 1. Now here, so from this bottom surface onto itself, the value of shape factor here, F11 value, this is equal to 0. Now here, yes, F12 is given as this is 0.2, F13 value comes out to be 0.8. Now as we have F13 value, we need to substitute these values. What is the area of the bottom surface? So area here is nothing but pi by 4 d square. What is the area of this member? So which means the diameter here is given as 5 meter. Pi by 4 d square is the area of the bottom plate into shape factor here is given as 0.8 into 5.67 into 10 power minus 8, okay, into T1 power 4. What is T1 here? 800 power 4 minus the value of temperature. So this is 500 power 4. Okay, with simple calculation, the answer comes out as 309.141 watts. So this is the answer that we get for this particular case. Now there was one more question. Okay, there was an ice block here. So here, so it is placed in the surrounding air. Okay, and he says that this ice block, so this was given as minus 70 degrees or something. It was a negative temperature. The exact value is not known actually. Now here, as this is surrounded by air, so he is asking us to identify what is the motion of air. As we can sense that there is natural convection here. See here, because of this cool, so very cold block, okay, what will happen to the air? The air is at 30 degrees centigrade. Obviously there will be heat exchange between the air and the block. So here obviously the air tries to cool down. Okay, so as it is trying to, the air is trying to lose its lose its heat. So what will happen here? As it is dropping its temperature, see, as it is cooling down, the temperature will drop. Now can you please say me, whenever the air cools down, its density increases or decreases? Now here obviously when temperature decreases, density increases. As density is increasing, it will try to drop down. Okay, so it will try to move in the downward direction. So here for this simple case, we can directly say that because of density differences, so due to heat transfer, heat exchange, as more density air tries to move down. So here in this case, overall we can say that the air will try to move in downward direction. Okay, so these are the questions that we have. So from machine design, strength of metals and heat transfer. Okay. So Wahid sir will give the answers to the theory of machines questions. Thank you.
Hello everyone. We are going to discuss the questions from theory of machines, and as you can see, the questions can be solved effortlessly and it is going to not take much time. And those who have referred the key points or short notes, all the questions could be attempted very easily. So here is the first question. An offset crank slider mechanism is shown in the figure below. The length of stroke of the slider is dash. So here the crank length is 30 mm, length of the connecting rod is 50 mm, and the offset distance is 10 mm. So stroke length, directly there is a formula. Let's say this is R, let's say this is L, and let's call this as E. So stroke length we can write it as root over L plus R whole square minus E square minus L minus R whole square, sorry, this should be L minus R whole square minus E square. So R is 30 mm, L is 50 mm, and E is 10 mm. And if you substitute all these values, you will be getting the answer closer to 60 to 63 mm. So straightforward question or recall type question, you will be able to see this. Next question. A block of mass 1 kg is connected to spring of stiffness 10 Newton per meter, is operating in viscous medium such that the damping ratio is equal to ratio of damped frequency to natural frequency. Damping ratio, that is zeta, equal to omega d by omega n, it says. Okay. The magnitude of damping ratio for the system is dash. So here you may find that the stiffness is given, but the mass is not at all. Yeah, mass is also given. Okay, so you can use the formula of damped frequency. Omega d is equal to omega n into root over 1 minus zeta square. So here it says that the damping factor is ratio of damped frequency to natural frequency. So this will be written as zeta equal to root over 1 minus zeta square. So when you square this on both sides, you will be getting zeta square is equal to 1 minus zeta square. So 2 zeta square is equal to 1, and zeta will be equal to 1 by root 2. So the answer would be 0.707 would be the damping factor. So again, this is also a recall type question. Next one, another question from the gears. The pair of spur gear is required to maintain velocity ratio of 1:2. So the velocity ratio is given as 1:2, or that is 0.5. The module of the gear is 10 mm and addendum is 10 mm, which means that we are using full depth teeth. Okay. If the operating pressure angle is 15 degrees, the minimum number of teeth required on the pinion to ensure no interference slash undercutting happens. So there is a formula for minimum number of teeth. Minimum number of teeth, T minimum, is equal to 2 times of, that is f into lambda divided by root over 1 plus lambda into lambda plus 2 sine square phi minus 1. So here lambda is 0.5, f will be equal to 1 because since we are using full depth teeth, so f is the addendum coefficient. So f is equal to 1, lambda equal to 0.5, and phi is equal to 15 degrees. So when you substitute all these values, you will be getting an answer as 24.2 something, so which is approximately 25 number of teeth are required over here. So this has to be an integer value. Okay. Next question. The system shown in figure below consists of cantilever beam with flexurial rigidity EI and negligible mass. So mass of the beam is ignored, and spring with a constant K and negligible mass. Mass of the beam is ignored and mass of the spring is ignored, and a block of mass M is attached. Assuming the lumped parameter model for the system, the fundamental natural frequency of the system is dash. So here if you observe this arrangement, you will find the beam and spring connected in the parallel arrangement. I mean, the simpler representation for this diagram would be beam, a mass is connected, and a spring on the top. You can remove this string or the extension to the mass, that is a rigid body, and mass instead can be placed here. So both mass and the both spring and the beam will be taking a parallel combination. And even if you observe the options also, you will find the addition of stiffnesses over here. It is the addition of the stiffnesses. So which means that the arrangement, in this arrangement, we are having the parallel combination for beam and spring. So here stiffness of the cantilever beam carrying a point load at the end is K is equal to 3 EI by L cube it is. It is a standard formula, and stiffness of the spring is given. So omega n will be equal to stiffness of the beam, that is K of beam plus K of spring divided by M. So K of beam will be 3I by L cube, so that is 3I by L cube plus stiffness of the spring divided by mass. So option C will be the answer, guys. Straightforward question, guys. Next one. Yeah. In the context of balancing of rotating and reciprocating masses, which of the following option is true? First option says that a single cylinder IC engine can be completely balanced using single balancing. See here, the IC engine is going to comprise of reciprocating mass. So balancing of reciprocating mass, that too fully, is not at all possible. Okay, even if you try to do that, the effect of unbalance will be present on the system, or we are just modifying the direction of unbalanced. We are not eliminating the effect of unbalance. So purpose here is to either reduce the effect of unbalance or eliminate. So reciprocating masses cannot be fully balanced. Next one, option B says that unbalanced rigid rotor can be completely balanced by using a single mass. Yes, it can be balanced, but here when we are using the single mass, the summation of forces will be equal to 0. So unbalanced rotor, if we consider over here, so let's say this is the point mass which is representing a rotor rotating on the shaft, and if we place a mass diametrically opposite to it, whether it is in the single plane or in a different plane, we'll be able to eliminate the unbalanced forces acting on the system. Okay, so here in the option B, he did not mention that the single mass, are you placing in the same plane or different plane? So there could be two possibilities. So when you are placing this in the different plane, then there will be unbalanced couple present on the system. So full balancing cannot be attained by the when you are using option B. Next, option C says that the unbalanced rigid rotor can be balanced by using two masses attached in two distinct planes. Yeah. And let me complete option D as well. A single cylinder IC engine can be completely balanced using single balancing mass. Option D is also incorrect, guys. So let me elaborate the option C. So here in the option C, if there is a rotor in the single plane, so what we are going to do is to balance this rotor, if we add one mass, we are going to get summation of unbalanced forces as 0, but the couple will be present. So in order to eliminate the effect of that couple, you are required to add one more mass. So a single mass can be balanced by adding two masses in the different planes. So option C is the answer. And here when you try to solve it, you will find the condition sigma F equal to 0 and sigma M equal to 0. That is summation of net unbalanced forces, whether it is in X or Y direction, will be 0, and movement of forces acting in X direction, acting in Y direction will be also 0. Then only the system will be completely balanced, or both dynamically and statically balanced. So option C is the answer. Okay, so these are the questions from theory of machines, and next Balaraju sir is going to take the discussion forward. Thank you everyone.
So dear students, coming to IM and war subject, so we have 3 questions. So those 3 questions from 2 marks side, so total 6 marks. And 1 question from inventory control, that is EOQ model with the price break. So 1 question from CPM and PET. Generally I used to mention many times in the classroom also. So the most important topics are CPM and PET and inventory control, the same like we had this time also. 1 question from forecasting, that is very simple question, MAD and MFE. Just let us have the solutions for those 3 questions. So this question from EOQ model with the price break. Then how do you answer this question? So we have to find out the minimum inventory cost if supplier was able to negotiate with the following price break. So we start with the lowest unit cost. What is the lowest unit cost in this? 8 rupees, just like a trial and error method type. So trial 1, let CU is equal to 8 rupees because the short lowest value 8 rupees. Okay, always smallest value generally preferred, and get the EOQ value. So what is the EOQ? Square root of 2 into D into C naught divided by CC. Just substitute the values. 2 into annual demand was given 3000 units, so 3000. C naught value 150 rupees. CC was given in terms of percentage, like a 40% of unit cost. So 0.4 into, what is the unit cost? 8 rupees. And if you calculate this, how much it is around 530 units. So this value 530. So what is observed? We have taken 8 rupees, but EOQ value 530. So it is failed, right? More than 1000 units, 8 rupees. So for availing 8 rupees, compulsory we have to order 1000 and above. But our EOQ value 530, so it is invalid. So this value is invalid, and what we do? We do compare the total cost. Okay, total cost comparison, how do we do? So total cost at Q is equal to 1000. So in order to get 8 rupees, compulsory we have to procure 1000 units. So Q is equal to 1000 and C is equal to 8. What is the equation generally we use? Q by 2 into CC plus D by Q into C naught plus D into CU, isn't it? So we substitute Q value as 1000, CC value as 40% of unit cost, D by Q 3000 upon 1000 into 150 plus 3000 into CE value 8 rupees. So it is around 24,000 is here 3.2. So total value how much it is? So just to check it out, it may be 27,249. 27,249. Actually, we have not yet obtained the EOQ value. Next trial 2. In the trial 2, what we do? Trial 2. CU is equal to next value 8.5 and get the EOQ. So EOQ at 8.5. So under root 2 into 3000 into 150 divided by 0.4 into 8.5. And this value, how much it is? 8.5 if you take now, it is around 514 units. Okay, just a minute. Like actually we have taken the previous case. This total cost is actually this total cost actually 26,000. 26,050. Next, this 514 is valid, so it is a valid EOQ. So this is valid. So total cost at EOQ we can estimate. What is the EOQ value? 514. CU is equal to 8.5 under root 2D C naught CC plus D into CU. So if you substitute in this, 2 into 3000, C naught value 150, CC 0.4 into 8.5 plus 3000 into 8.5, it is equal to how much? 27,249. Just compare the two values, like a minimum total cost is our requirement. So quantity total cost Q is equal to 1000. How much it is? 26,050. EOQ value, how much? 514. This is 27,249. So where you are getting minimum? Minimum total cost, actually minimum total cost is equal to 26,050, but there is a confusion regarding the question. So minimum inventory cost, if the question is minimum inventory cost, then directly we will take EOQ value. Okay, so there is a dilemma. Actually this question should be minimum total cost. Suppose if it is minimum total cost, answer could be 26,050. Inventory cost, minimum inventory cost means where we are getting minimum inventory cost. This one, 2 into 3000 into 150 into 0.4 into 8.5. So it is around 1749 minimum inventory cost. Minimum inventory cost is equal to 1749. Minimum total cost is equal to 26,050. 26,050. So my doubt is the question could be, must be minimum total cost. If it is inventory cost means then you can take 1749. Okay, got the point here? So generally the examiner will give only minimum total cost. So like we have not received exact data. It's only memory based question. That's why I'm not sure about this. So there are two answers you will get. Inventory cost means 1749. Again I'm confirming you. Inventory cost means 1749. That is EOQ. EOQ is always giving minimum inventory cost. And coming total cost 26,050. And coming to next question, this question from forecasting. Here you have to find out MFE and MED, mean forecast error and mean absolute deviation. Just simply MFE is equal to what we can take, MFE error, like a sign also we consider. Compulsory we have to take negative or positive, but in case of MED no need to take the sign. So first I am taking the MED. So MED is nothing but the difference of these two, 425, 427, difference how much? 2 plus here 7, 4, 8, 4, 2, 3, 2, 4, 15, 21, 6, 9, 13, 21, 25, 27, 30, 32, 34, 36 by 10. 9, 13, 21, 25, 27, 30, 32, 36 plus 6, 42. 42 divided by 10, no, 4.22. MED is equal to 4.2. And coming to MFE, we are going to take the sign also. So 425, what is basically error? Error is equal to dt minus ft. So you take the same MFE, 425 minus 427 minus 2, just let me give the value directly, minus 2, minus 7, plus 4, plus 8, plus 4, minus 2, plus 3, minus 2, minus 4, plus 6 divided by 10. It is around 8 by 10, how much? 0.8. So MFE is equal to 0.8, MED is equal to 4.2. Very, very simple and silly question for 2 marks. So next, find the slack at D. Actually, slack is only estimated for event. Float is estimated for activity. D is activity. So the question could be, it is not actually slack. It must be float. Float or total float. Even float, the word is the right word. Okay, slack means only event oriented. Anyways, then how do you find out the slack value? Easily, just you can take the paths. There are how many paths in this? A, B, D, G, H. A, B, D, G, H. So what is the duration? 12, 14, 17 plus 9. 12, 14, 22, 26. Next, A, B, E, H. Along this path, what is the duration? 12, 19 plus 9, 28. Next path, A, C, F, H. Along this path, what is the duration? 9, 6, 15 plus 9, 24. So what is the longest path in this? ABEH is the longest path. Now we can find out slack value right now. 28 is a reference. Slack of this path is equal to slack for this path. Say I am calling it as a path 1. 28 minus 26, 2. This is actually I am taking path 1, path 2, path 3. Slack it to path 2, 0. Slack it to path 3, 28 minus 24, 4. So whatever activity on that path will have this slack value. So the question is D. D, where we have D, D is on path 1, so what is the slack value? 2. Directly we can take, or else do like this. At each and every event get the earliest and latest values. Here how much? 19. 19 plus 9, 28. 28, 19, 12, 4, 0. Along the critical path I got the values. 19 minus 3, 16. Suppose you take total float for D. Total float for D is equal to maximum available time minus required time. What is the maximum available time? 16 minus 12. Maximum available time minus required time 2. So how much? 2. Any method you can use. I think this is the best. So different paths we have. What is the difference of the paths? Nothing but slack. Slack of this path is equal to 2. Obviously D will have 2. Or else you can find out total float. So this is regarding IM and OR subject.
students, I am Dr. Manikumar. Now coming to mathematics questions. You see the first question, directional derivative of the function f given below the point 1 comma 0 at the point 1 comma 0 in the direction of one vector given. So directional derivative we are asking here. Solution. Okay. Direct, what is the function here? Function is given as f of xy is equal to x square plus xy square. F of xy is nothing but x square plus xy square. Okay, first you find the gradient of f. Del f is nothing but what it is? Dou f by dou x I bar plus dou f by dou y j bar or not. So partial derivative of f with respect to x, what it is? That is 2x plus, with respect to x means 2x plus y square I bar plus partial derivative of f with respect to y means what it is? That is 2xy, y square derivative is 2y, okay, into x j bar. Okay, at a point 1 comma 0 they are asking. So del f at a point 1 comma 0, what it is? In place of x 1, in place of y 0, that is 2I bar. This is 0, completely 2I bar. Now directional derivative of f in the direction of a vector a bar. What is the vector a bar here? Given a bar is equal to one vector a bar given here or not? What is a bar? Vector a bar is nothing but 1 by 2 into I bar plus root 3 j bar. That is nothing but 1 by 2 into I bar plus root 3 j bar. That is nothing but 1 by 2 I bar plus root 3 by 2 j bar or not. So what is directional derivative? dd is nothing but, already you know, del f dot a bar by modulus of a bar or not. So what is del f? Del f is nothing but 2I bar dot product a bar by modulus of a bar. So what is a bar? 1 by 2 I bar plus root 3 by 2 j bar by modulus of a bar means root over what it is? Root over 1 by 4 plus root 3 by 2 whole square means 3 by 4. Now you take the dot product. What is the dot product here? So here j is missing means that would be 0. That is 2 into 1 by 2 is 1 here. So that is 2 into 1 by 2. Denominator is nothing but root over 4 by 4 means 1. Finally we will get 1. So directional derivative in the direction of a vector a bar is nothing but 1. Clear or not? Now coming to the next problem. In the closed interval 0, 3, the minimum value of the function given below. So in the closed interval 0, 3 means interval specified in sense here we have to find global minima within that interval. So first what is f of x? F of x given as 2x cube minus 9x square plus 12x. 2x cube minus 9x square plus 12x. What is f dash of x? That is 6x square minus 18x plus 12. Okay, first stationary points required or not? Put f dash of x is equal to 0. That implies x square, take 6 common parallelly, minus 3x plus 2 is equal to 0 means what are the values of x? X is equal to 1 comma 2 are stationary point. So substitute the stationary point along with the end points in the given function where you get a minimum value. Okay, that is a global point of minima, output is a minimum value. So what is f of 1? Substitute 1. F of 1 is nothing but here 2 minus 9 plus 12. 2 plus 12 is 14, 14 minus 9 is 5. Okay, next what is f of 2? F of 2 is substitute to 2, that is 2 into 8. 2 into 8 is 16. 16 plus here 12 into 2, that is 24, 40. 40 minus 9 into 4, 36. 40 minus this is 4. Okay. At endpoints you can substitute directly because interval specified instance you have to substitute endpoints also. At endpoints. At endpoints, what is the first endpoint? 0. What is f of 0? F of 0 is directly you are getting 0. But what is f of 3? F of 3 is nothing but 2 into 3 cube is 27, that is 54. 54 minus, okay, 9 9s are 81 plus 12 3s are 36. So this is nothing but 90 minus 50 plus 36 means 54 plus 36 means 90. 90 minus 81 is nothing but 9. But they are asking global minimum value. What is the minimum among all these values? 5, 4 and 0, 9 minimum value is nothing but 0 only or not. Therefore, minimum value in interval 0, 3 is 0. So what it is? Option C is correct. Clear? Now coming to the next problem. If C is a unit circle in complex plane with its center at the origin, what is unit circle? Unit circle means center 0, radius 1. Center 0, radius 1 means what is these endpoints? This is 1, this is minus 1, this is I, this is minus I. So what are the singular points here? For the C, already integration value given, integral f of z dz is given as 2 pi I n, 2 pi not in, this is actually 2 pi I into n it seems to be, okay, because they are asking n value in the equation. Okay, so what are the singular points here? Clearly here singular points is, one is z is equal to, singular points are nothing but z is equal to, z square plus 4 is equal to 0 means z is equal to plus or minus 2i. Next, z is equal to plus or minus 2. Say this, 2i lies here, minus 2i lies outside. Okay, plus 2 and minus 2, all singular points lies outside. All singular points lies outside is, and there is no singular point inside this circle. There is no singular point inside this circle means this integration would be 0. Is it right or not? So integration is 0 means, therefore 2 pi I n value 0. Therefore what is n? N should be 0. Clear or not? So here n is 0. Coming to the next problem. If two unbiased coins are tossed, then what is the probability having at least one head? Two unbiased coins are tossed. Two unbiased coins means what is a sample space? Okay, both may be heads or head-tail combination, tail-head or tail-tail. It's very simple question, or very simple question it is. Okay, probability of having at least one head. Probability at least one head means one or more number of heads. At least one head. Here head is there, here head is there, here more than one head. At least one head means minimum of one head. How many favorable cases are there? Probability of at least one head. Total 4. Out of 4, how many favorable cases? There are 3 favorable cases. Either one head or more than one head. 3 by 4 means 3 by 4 is not there. Okay. 0.75. 0.75 means option A correct or not? Clear? Now coming to the next problem. Differential equation given. This is Cauchy-Euler linear differential equation with variable coefficients. Okay. So conditions given. First I have to solve the differential equation. Okay. Using these conditions I have to find C1 and C2. Okay. Yet x is equal to answer given. We have to find A. What it is? Given D, given differential equation is, given dE is x square d square plus 3xd plus 1 into y is equal to 0. This is Cauchy-Euler linear dE means what is xd? Xd we can assume as theta. X square d square is equal to theta into theta minus 1. Already we know x is equal to e power z, then z will be log x or not? Already you know. So it will be theta into theta minus 1 plus 3 theta plus 1 into y is equal to 0. Then what it is? Theta square plus 2 theta plus 1 into y is equal to 0 means theta plus 1 whole square into y is equal to 0 or not. So, what is auxiliary equation? Auxiliary equation is theta plus 1 theta plus 1 whole square is equal to 0. That implies theta is equal to minus 1 or not. Theta minus 1 means roots are real and repeated. Therefore, what is y of z? Already c1 e power minus z plus c2 z e power minus z. Convert z variate to x variate. Y of x is equal to what is y of x from this? So, e power z x means what is e power minus z? 1 by x. So, c1 into 1 by x plus c2 into z is nothing but log x or not? c2 into log x into 1 by x. Clear? Let it be 1 because here conditions also given. In one of the condition derivative given means find its derivative too. What is y dash of x? That is c1 into derivative of 1 by x is minus 1 by x square plus c2 into uv rule you can apply log x into minus 1 by x square plus 1 by x into log x derivative 1 by x. So, 1 by x square. Let it be 2. What is the first condition? At x is equal to 1, y is equal to 0. Given y of 1 is equal to 0. Substitute in 1. 1 implies, if I substitute in 1, input 1, output 0. Okay. So, input 1 means in place of x, output is 0. 0 is equal to in place of x 1 means c1 plus, here log 1 is 0. That implies c1 is equal to 0. What is the next one? At x is equal to 1, see, derivative at y dash of 1 is equal to 1, output 1 at x is equal to 1. Y dash of 1 is equal to 1, substitute in 2. 2 implies, okay, output is 1. What is input in place of x? Substitute 1 again. So, minus c1 plus c2 into log 1 0 or not. So, this is 0 plus 1. Clear? Already c1 is 0. So, 1 is equal to this is 0 plus c2, that implies c2 is equal to 1. Okay. So, c1 0, c2 1 means rewrite the equation. From 1, what is y of x? Okay, with c1. c1 0 means ruled out, first part no need to write. c2 is 1 means log x into 1 by x. This is a final answer. But at x is equal to 2, what it is a log 2 given? Y of 2 is nothing but 1 by 2, x is equal to means y of 2 is equal to 1 by 2 log 2. But at x is equal to what is given? A log 2 given. See, at x is equal to we have got 1 by 2 log 2, but in the given data at x is equal to a log a ln 2 given. So, what is a and what is say log 2 log 2, you compare these two, therefore what is a? A is equal to 1 by 2. If you compare both, a value is 1 by 2 or not? They are asking the value of a or not? The value of a is. Clear? Yes, coming to the next problem. If A and B are real symmetric matrices of same size, then which of the following is true? Maybe based on the given data, yes, this question I am giving here. According to the data, A and B are real symmetric matrices. Okay, but A transpose is equal to A inverse. A transpose is equal to A inverse. Okay, it is not a property of a symmetric matrix. It is a property of orthogonal matrix. So, option A wrong. A is equal to A inverse. It is a property of involutory matrix. For involutory matrix, A square is equal to I. A square is equal to I means A is equal to A inverse. This is also not correct. AB is equal to BA is a direct commutative, say commutative property may or may not hold good for symmetric matrices. Okay, not sure. Symmetric need not satisfy commutative always. So, this is also wrong. This is a direct property. AB whole transpose is equal to B transpose into A transpose. If A and B are same matrices, square matrices of same order, so They need not be symmetric. Directly, this is a direct property. AB whole transpose is B transpose. Irrespective of the symmetric, this property satisfies. So, based on the given information, option D is correct. Clear? Direct question it is. The divergence of a curl of vector, direct vector identity it is. What it is? Divergence of curl F is always 0. Divergence of curl F is always 0. Divergence of the curl of a vector field, that is 0. Vector identity it is. Option A correct. Okay, next you see this problem. Solution of the PD, dou square u by dou x square plus dou square u by dou y square is equal to 0. Actually, it is Laplace equation, but from the options we can verify easily. Which option satisfies the given PD? That would be a correct option. Okay, no need to solve the complete problem. So, here you see from option C. You can ask, generally one doubt you can express, why you are choosing option C only. See, this is directly, even in from the complex variables also if you write, that is nothing but e power x into, say this, e power z is nothing but e power z is analytic everywhere. E power z is analytic everywhere means this is e power x plus iy. That is e power x into e power iy is nothing but cos y plus I sin y or not. Okay, see, in an analytic function, this is in a form u plus iv, both u and v are always harmonic functions. Harmonic functions means what is harmonic function? If any function satisfying dou square phi by dou x square plus dou square phi by dou y square is equal to 0, that is always harmonic. So, e power, if I take u is equal to e power x sin y, no doubt it is always harmonic, it satisfies that condition. Okay, you cross check it if you have any doubt. I am taking from option C, I am taking u is equal to what it is? E power x sin y. Ux means dou u by dou x. With respect to x means keep y as constant, that is sin y. Uxx, partial derivative with respect to x again means dou square u by dou x square. Again e power x sin y. Okay, now coming to uy. What is partial derivative with respect to y? Means e power x is constant now. E power x cos y. Uyy. Derivative of cos y is minus sin y or not? So, minus e power x sin. Now, add these two. Uxx plus uyy. Uxx means dou square u by dou x square. Uyy means dou square u by dou y square. That is, add these two, you are getting 0 or not? But no need to do like this, directly from complex variables. Okay, in an analytic function u plus iv, u and v are always harmonic functions. Okay, so these are the questions in mathematics. I hope you all did well. Okay, all the best. Now, next aptitude sir will take the session.
Good evening, friends. From the general aptitude, we are getting the some questions only, memory-based questions only. 100% is right information, 99% is right information from our student. We are getting one of the student, Neenad. Okay, Neenad. From your source, I am telling the answers. Neenad, from Pune branch student. Okay. And Kakinada JNT student, he said 12 out of the 15 marks, all the best. Okay, thank you Shiva, all the best also. Right, first one, fish shoal, line. So fish means group of the fishes is called shoal. So group of the lines is called pride, one of the question. Next, hide 19, 23, 7, 11 given. Case 5 to 17, 11 given, then HIGH. So here letter to number given. So particular letter, particular number, okay, any increase, any decrease, not like that. Coding point of view given, you can observe here H, okay, H, observe 19, I 23, assume, D is equal to 7, E 11, E 11, right or wrong? So here also E available, so 11. So E meaning 11, corresponding place is same. Corresponding place is same. So E last place is 11. E last place is 11. So corresponding place is same. You can assume. Okay, Ninad. So here, then what is HIGH? According to the options, based on the options, H value 19. Here last one also 19. So middle one you can consider. Based on the options. So 2 times repeated number, option B is available. So 19 and 19. So that is the right answer. Next, this question, my dear friends, from the directions, okay, very easy concept. P and Q start from the point X at 10 a.m. P travels in north direction with velocity of the 25 km per hour and Q travels in the east direction with the velocity of the 30 km per hour. Q stops sometime, okay, Q is waiting sometime, for some time. After traveling for 1 hour, so for how long did Q stop? If both have covered the same distance at by 11:30. Okay. So P and Q. P towards north, after 1 hour. Okay, after 1 hour. After 1 hour. So P cover 25. Okay. Here Q cover after 1 hour. So Q cover 30. Here Q is waiting some time. How much time I don't know. At the time of the 10:30, okay, this is 1 hour. At the time of the 10:30, so this one, okay, 25, half an hour. P and Q start from point. P travels in the north direction with a velocity of 25. Okay, so half an hour. So 12.5, 37.5. Okay, so after how much time? Okay, so 37.5. In a 37.5 required 7.5. 7.5 means in a 37 point means 1/4, 1/4. 1/4 meaning 15 minutes. So he is waiting 15 minutes only. He is waiting only 15 minutes only. Okay, Q is waiting 15 minutes only. This is the concept, my dear friends. Okay, Q is waiting 15 minutes only. Then P and Q cover same distance. Next. And here one more question, my dear friends, from the probability, everybody knows, okay, who are attended the class, everybody knows. If 2 coins are tossed, unbiased coin, if 2 coins are tossed, what is the probability getting at least one head? What is the probability getting at least one head? At least one head. Okay, 2 heads. So 2 heads, okay, 2 heads, coin 1, coin 2. So at least 2 heads means head to tail accepted, tail head accepted, both are heads accepted. At least one head. At least one head means 1 also accepted, 2 also accepted. Okay, so 3 chances. So out of the 4 chances, 3/4 is the answer. But according to the option, fraction not given. Okay, so the answer 7.47, so 28. Okay, 0.75 is the answer. Remember, 0.75. My dear friends, same question, almost 3 years back question. What is the probability getting at most one head? Same question. Already you know, my dear friends, all of you. Okay, who people listen the classes and overall, you know the logic. Okay. So based on the students' information, our AS or any online test students' information, out of the 15, easily getting 10 marks based on the student information. Okay friends, these are the concepts received from the students, only pure memory based, not exactly. Okay, so pure memory based questions only we received from the students. Okay friends, all of you, you did very good job. Each and every student getting good rank friends. Thank you, all the best.